Hi, everybody. I am Paul Morie. I'm an engineer at Red Hat and a chair of SIG Multicluster in Kubernetes.
And I'm Jimmi Olmsted-Thompson. I'm an engineer at Google, and I'm also a chair of SIG Multicluster.
And this is the SIG Multicluster intro at KubeCon EU 2020.
So thanks for joining us. A little overview of what we're going to cover. First, we're going to talk about what the SIG is about and how you can contribute. And then we're going to talk about the history, how we got here, the evolution of Kubefed v1 and 2, and the cluster registry. And then we'll go into what's happening now. We have a multi-cluster services API. We have a new work API project. Kubefed v2 is still evolving, and we're going to talk about a cluster registry rethink.
So this SIG deals with an extremely broad topic. It touches a lot of different problem domains. It touches a lot of different functional areas. The best definition that we can give for what the SIG is about is that it's about making multiple clusters work together somehow. We are several years into the work of the SIG, but we're really still working to identify what the best and most durable primitives are in this very complex domain. And we need your input. Real user stories and use cases are extremely valuable to figuring out what the best problems to solve are and how best to solve them. Many of the projects that we have going now are still in the alpha stage, and they're still very malleable. The first project that we can really attribute to the SIG is a project that many people have probably heard of called Kubernetes Federation. The Federation project is about spreading copies of a resource to multiple clusters and possibly overriding those resources or parts of them for certain clusters. The original Federation project was implemented as a special set of controllers that backed something that was very close to the normal, if you can perceive my air quotes, Kubernetes API server, plus a new resource called cluster that modeled which clusters Federation should spread resources to. You can see on the right-hand side of the screen an example of a replica set that is intended to be used with Federation. And I'll just draw everybody's attention to a few key things here, because they express some of the things that we ultimately found to be limitations with Kubefed v1 or Federation v1. The first is that you might notice if you look at the API version and kind, that this is the exact same API version and API surface as for a typical replica set. That means that they present the same way in the federated API surface and the normal API surface. You might also notice that there are some annotations on here that express different Federation features. This is something that we ultimately found to be hard to support and evolve. And some other limitations that may not be evident from this example resource are that the Federation v1 required custom code for each resource and did not support CRDs at all. We got to a point in the SIG's lifetime where Federation v1 hadn't really been widely adopted. It wasn't supported by any major vendor, and there was also not a consensus in the community about exactly what the right problems to solve were. The folks that were contributing at the time all got together and tried to determine where there might be areas of overlapping interest, and where there might be some consensus about perhaps some individual problems to solve that were part of a greater whole. And the most agreement that they could find was basically that there needs to be a way to track multiple clusters when you're dealing with multiple clusters. And that's how the cluster registry concept came about. And the purpose of the cluster registry was to try to solve the problem of tracking multiple clusters. But we'll find as we talk through the history further that the cluster registry concept is perhaps a little bit more difficult to describe than you might think. Let's talk about Kubefed v2. Similar to Kubefed v1, the API surface of Kubefed v2 is really all about a template resource being pushed to some clusters that have been joined with the cluster that hosts Kubefed. We worked hard to address some limitations of v1 from an API mechanic standpoint. So for example, Kubefed v2 heavily leverages CRDs to create a new Federation API surface for any type. It was felt that this was really important so that we could make a distinction between the normal API resources and the ones that had a meaning in Federation. Another challenge that we had to solve in Kubefed v2 is that when Kubefed v1 was created, there was no concept of extending the control plane and dynamically creating new API surface. And of course, today, one of the things that is central to how people use Kubernetes is that users can define their own types using CRDs. So a key challenge that we tried to solve was to build a Federation project that was usable with types that we didn't know in advance. So the way that Kubefed v2 wound up handling this is that there is a API for Kubefed itself that you use to create new API surfaces for resources that you want to spread around with Federation. And you can see on the right-hand side of the screen an example of a resource like that. Let's take a look at this really quick, and we'll see if we look at the spec for this federated resource, we'll see a template field that contains the definition of the template resource. We'll see also a placement section, which contains information about which clusters this resource should be spread to. And we'll also see at the bottom overrides, where when this resource is placed into cluster 2, the replicas field is overridden to the value of 5 instead of 3. So we solved one set of problems and addressed some of the limitations of v1. The solution ultimately turned out to introduce a new problem, which is that having a distinct API surface for Federation means that existing resources and normal resources require transformation to be used with Kubefed v2. So for example, if you have a Helm chart that you're using to deploy something, in order to use that with Federation v2, you would have to transform the content of that Helm chart. And what we found is that for many users, this introduces an extra barrier to entry. We'll come back to what we think might be more durable for some users when it comes to the API regime of how to model spreading resources onto external clusters. But I want to call attention back also to the question of the cluster registry. We attempted in a couple different ways to integrate Kubefed v2 with the cluster registry and to pull functionality that we had originally implemented in Kubefed v2 for joining external clusters to the cluster hosting federation up into the cluster registry. But the corrected boundaries between Kubefed and the cluster and the cluster registry were never really apparent. So we can probably see by now that one of the central challenges that we have in this area is exactly how we should track clusters, that software that works with multiple clusters is interested in working with. The real challenge that is, or one of them anyway, that is part of creating the cluster registry is that it's really easy to talk about conceptually. A lot of you that may be watching that maybe haven't seen this content before might be kind of nodding your heads that it makes sense that you should have a list of clusters or a set of clusters to track. But it turns out to be really kind of difficult to frame up exactly what that means and how that translates into software that accomplishes something useful to users, but is focused on that registration type of primitive. The other tricky thing about that, about the cluster registry problem, is that it's very tempting to try to build a cluster registry first because it seems easy. We have kind of gotten to a place in the SIG where I think we recognize very well that it's a bit of a strange attractor. It seems like something that you can kind of knock out. It's proven not to be, though. And the feeling in the SIG currently is that we want to rethink the concept of registration and tracking clusters, starting with the most essential use cases. And this is one of the areas where we really need your help in the SIG, because we don't want to overfit a solution for a small number of use cases and ignore ones that people have out there that we just don't know about. So I'll make a plea here for you to help us by telling us what's important for you to get from the community. In our current efforts that we're going to talk about in sort of the second logical part of this talk, I want to make it clear that we're trying to avoid characterizing a registry as a first step. Instead, we want to focus on the most essential parts of the problems that we're trying to solve and kind of work backwards to the registry concept.
So let's talk about the Multicluster Services API. So first, services are a multi-cluster building block. They solve a specific problem, but everybody kind of needs to solve this problem. No matter how you want to have your clusters working together, you need some way for them to communicate. So we started building on the concept of namespace sameness, and that is that a namespace should have a consistent meaning throughout your clusters. Not every namespace needs to have some multi-cluster significance, but you probably want to avoid a situation where a given namespace means something in one cluster and something entirely different in another cluster. And if you have a multi-cluster namespace, you probably want it to be somewhat consistently multi-cluster and not pick and choose which clusters are exposing a namespace and which aren't. So to start, we've focused on really just trying to define the API needed to allow common behavior and tools to develop. We wanted to come up with the bare minimum that we needed so that there could be a common way to talk about a multi-cluster Kubernetes service, but we wanted to leave room for various implementations. So for example, a control plane can be centralized or decentralized with this model, but for consistency, consumers only ever need to rely on local data. If you take a look on the YAML here on the right, you see a very simple service definition. It's just a regular single cluster service, but to make it multi-cluster, you create just this other named map service export resource, and that signals to whatever implementation you're using that multi-cluster service should be created and exposed to the other clusters in your group. Now, this is still a work in progress. We need implementations and input, so please come join us and help us out.
One of the ongoing projects that we have in the SIG is that I'm very excited about is the Work API. The Work API has a slightly different pattern for distributing resources than the federation patterns that we've talked about. One of the things that that I personally took away from my prior work on Federation is that distributing individual resources, while it works very well for some people and some use cases, a lot of users that I've spoken to are really after not distributing individual resources and saying, I want to change this field about this resource. Instead, they want to distribute a collection of resources that build up to a greater whole. So, for example, instead of distributing config maps and replica sets or deployments or your CRD, distributing the entire application or entire collection of things to make something work. This is currently in a pre-alpha state, a pre-kept state, but it's something that we spent a bit of time in the SIG talking about, and that I expect to be one of the central things that we'll work on in the next 6 to 9 months. And again, talking about how working backwards touches this, initially where our focus is about how is best to characterize an API that deals with expressing that a particular collection of resources should just be applied on a single cluster somewhere. To just try to solve that most essential part of the problem that exists at the boundary between a place where the work definition lives and the place where we want it to be applied. Next steps, once those problems are solved, or that we have some good working state that they're in, are to think about how this touches the registration concept and how it touches a scheduling concept. So for example, when it comes to registration, how does the cluster where the work is to be applied, how does it become aware of the source of the work and vice versa? So how does a reconciler, say it's a pull reconciler running on a remote cluster, understand where to look to pull its work from? And how does it gain access to be able to watch and do other API operations on the cluster where that work lives? Again, this is still a work in progress. Your input is extremely valuable here, both use cases that you're interested in, prior art, and especially learning experiences that folks have had from, maybe you've implemented an API like this yourself, or maybe you have a tool that does this job for you that you really like. We'd love to hear about all that. And I want to take a moment here to just give a shout out to Valerie Lancey for her contributions and catalyzation of this particular problem space. Valerie has done a lot of really awesome prototyping work and wrote a very thought-provoking blog post that really was the catalyst for us to begin taking this up in the SIG. So thank you very much, Valerie. We really appreciate the work. Next, let's talk about Kubefed development, which is still underway. I want to just call out that there's no one-size-fits-all solution in this really complex and frankly sometimes confusing problem space that's going to work equally well for every user and every use case that every user has. The Kubefed model works well for some users and use cases, and I want to give a shout out here to Jimmy and Hector and others from D2IQ for helping to move the project forward. One of the most interesting things that the Kubefed project is considering now is how to add pull reconciliation. The initial implementation of Kubefed v2 uses a push reconciler model, meaning that there's a controller running in the hosting cluster that is pushing via API calls resources to the remote clusters that are joined to it. This is interesting because it comes back to that cluster registry concept. How does a pull reconciler running in a remote cluster gain access to observe the cluster where the Kubefed API surface exists? So that cluster registry problem is kind of popping up again and waving at us. All right, back to you, Jeremy.
So hopefully we've done a good job of kind of explaining that a cluster registry is harder than it sounds. Yes, we need one. Most likely, we just don't know exactly what it is. So the more use cases we have, the easier it will be for us to understand what the boundaries should actually be, what should be included in that cluster registry, what should be defined in the API, and what can be an add-on or other implementation. We can only know this if we know what your use cases are, and if you tell us. There are some things that are pretty obvious, like there needs to be a concept of a cluster identifier to identify each cluster. And we're seeing from the multi-cluster services implementation that that identifier probably needs to be a valid DNS label and definitely needs to be unique, but we don't know what else is going to be required. So what are the other building blocks that we're missing? Come join our meetups, tell us your use cases, help us understand all the spectrum of what needs to be covered with a cluster registry.
All right, that's our talk. We look forward to hearing your questions live, and just want to say thank you everybody for attending today.
Thank you all.
Everybody stay safe, and we'll take your questions in a moment. Thank you.